Hey guys, finally a little break in, this will be the last of the videos for a little bit. We're going to look at again lesson 7-4 and lesson 7-5, and we're going to be solving word problems with multiplication and division. Today's date is the last day of February. Yeah. Okay, 2/8/28/19. All right, so when we solve word problems, we talked about in the other set of notes on adding and subtracting that we read the problem a couple times, and then we're going to go ahead and define variables, be specific as possible, and so on. So I'm just going to kind of cut to the most important pieces, thinking about how you're going to get graded. So, word problem process. This is assuming you've read it, okay? At least, oh, sorry, I forgot the word problem process. Got to finish my own title. See, I start talking, I forget what I'm doing. So, first and foremost, after we've read the problem, we have to figure out what we're solving for. So, you're going to choose a variable, whatever letter you want, and define what it represents. Now, that simply is me saying, tell me what words your variable represents in this situation. So define what it represents. Okay? And be specific. So let's see. Let's say we're talking about Bob's age. I would not define Bob's age as X equals Bob. Okay? That's not very specific. What about Bob? Bob's age. Okay. And you could even be more specific. When are we talking about his age? Now, last week, next Tuesday, in a year. Okay? So be as specific as you can. Once we have that variable, that's going to hold the place of the words we didn't know how to turn into a number or an operation because they wouldn't. That's when you're going to translate the equation. Now, I'm going to keep repeating myself on this stuff because you got to get it into that brain, right? So, you're going to either do it word by word or word by phrase. Oops. Or it could be phrase by phrase, right? So sometimes we just have single word translates into one thing, like 4, F-O-U-R. Oh, that's the number 4, okay? And then you could have less than, oh. Those together mean to subtract and to switch the order, okay? So that's the kind of stuff we're talking about. All right. Now, when you translate, we talked about this in class today. Like I said, years and years of either teaching out of a math book and a lot of different ones, or going through a math book as a student. I think there's been one time when the actual translation had variable equals number, math, number. So that's what a lot of people are trying to do, because they're trying to already start solving the problem, okay? So, number one thing to remember, the variable is not alone, not during the equation part, right? It's when we solve it, we're going to solve it to get alone, okay? So if you have something that looks like this, this is actually you trying to solve the problem. The real problem should be 5x equals 25, okay? All right, so what are some of the things that I'm going to be seeing here? I'm going to see variable, or it could be more than one. Not likely, but in higher math, we sure get more than one variable. We could see one operation, or we could see more than one operation. So I'm going to say operation or operations. We're going to see number. Actually, we should always see at least 2, okay? And then we need to see an equal sign. And when we get into Chapter 8, after we finish this piece, then we're also going to see an inequality sign. Could be the kind of separating one half of the equation from the other, okay? And then, as always, we're going to solve using inverse operations. So I'm trying to redeeming myself. Solving using inverse operations. Instead of writing solving inverse or inverse operations. Solve. I don't like the word solving. Let's just say solve. I think that sounds better. Solve using inverse operations. Okay, and we've talked about how addition undoes subtraction, subtraction undoes addition, multiplication undoes division, and division undoes multiplication. And then last but not least, what does the answer look like? So the answer, no variable. Okay, no variable. And you're going to write it as a sentence. So write answer in a sentence with labels and context. So labels are feet, meters, inches, years, so on and so forth. What is the number being measured in? And context is what was going on in the situation. So like the example we did together in class, you had May and Julie were saving up points to earn a pizza party. Okay, so her getting those points, either one of the girls, they would be able to have that pizza party. So that's kind of the context. All right, so we have 3 examples. And just because not a lot of space, I'm just going to go ahead and go to the next screen and bring in my first problem. All right, so Vicente and some friends shared the cost of a package of blank CDs. The package cost $24, and each person contributed $6. How many people shared the cost of the CDs? Now, this looks like a pretty stereotypical situation. Vicente and some friends shared the cost of a package of blank CDs. So they're giving us an idea of what we're talking about here. The package cost $24, and each person contributed $6. How many people shared the cost of the CDs? Notice it ends with a question mark. So that question mark is going to help us define our unknown. So I'm going to say X equals how many people shared the cost of the CD. So instead of writing it as a question, I'm going to change it into a statement. Number of people sharing the cost of the CDs. Okay. So the package cost $24, and each person contributed $6. Okay. So 24 and each person contributing $6. They balance each other out. So my equation can be written one of 2 ways. 24 is the same as what it's going to be for $6 per person. So we can write it that way because the 24 showed up first. But remember, we can use the symmetric property and rewrite it as 6x equals 24. All right, so far we've got 2 of the 4 things I need to do. Third thing is I need to solve the equation. How? Using inverse operations. So what math is happening between the 6 and the x? Remember, if we don't see it, it's multiplication. So the inverse of multiplying is dividing. And we're going to divide by the number that's on the same side as the 6. Why? We want to get, the same number that's on the same side as the variable. Why are we doing this? Because we want my reciprocals, 6 and 1/6. When I do that math, I get 1. 1 times x equals x. And then on the other side, 24 divided by 6 equals 4. So then I take that answer, and I'm going to take the definition, and I'm going to substitute in 4 into that definition. So I'm going to say 4 people shared the cost of the CDs, sorry. Okay, and that would be the answer to this one. All right, I think I'm going to bring in my second example. I think I can fit it in on here, and then we'll do that one. So hold on. So remember what your job is. You've cut apart your word problems, and you are gluing them down or taping them down into your notes, just like I'm quote-unquote gluing mine in as well. So example 2, Ken and Ty are sharing a pack of Pokemon cards. Each boy gets 11 cards. How many cards are there in all? Okay, so let's think about this. Ken and Ty, so we got 2 boys. Each boy gets 11 cards. How many cards are there in all? So the very first thing we're going to figure out is how many cards are there in all. So the number of total cards. So in other words, we have a pack of cards, a bunch of cards, a pack of them, yeah. And then we're going to split it amongst 2 friends. Okay, so that sounds like division. So here's my equation. I'm going to take the number of cards, split it amongst 2 friends, and each boy ends up getting 11 cards. Okay, there's 2 of my things. Next thing I need, solving. How do I do that? Well, the inverse of dividing by 2 would be multiplying by 2. And remember how I talked about you got to do that up nice and high. So we have one number on the left in the numerator and one number in the denominator. So what's 2 divided by 2? That equals 1. And then x times 1 is x. And we get equals 22. So how many cards are there in all? We're going to say there are 22 cards in the pack of Pokemon cards. Now, I hate to admit to this, but I've never bought a pack of Pokemon cards, so I don't know if that's stereotypical to have 22 cards in there. So maybe you guys can answer that question for me when I see you on Friday. Okay? All right. We've got one more, and obviously I've run out of room here, so I'm going to go to my next screen, and I'm going to pop up my last example. Okay. Last but not least, we have Chuck is buying a ham. Good for Chuck. He wants to divide it. Oh, man, they just threw it on our face what we're going to do. He wants to divide it into 6.5-ounce servings for 12 people. What size ham should Chuck purchase? Okay, sounds like somebody's trying to get ready for Easter because people like to have ham on Easter. So he's trying to figure out what size ham he should get so that each of the 12 people are going to get 6.5 ounces of this stuff. Okay, so what are we solving for? The size of ham Chuck should purchase. So again, instead of writing it as the question, I am writing it as a statement. Oops. And I'm just stealing the words from the question. Okay. So it says he wants to divide it. So guess what it is? the ham, right? So he wants to take the ham and divide it into 6.5 ounce servings. Now, I'm not going to put the labels there, okay? I'm only going to put the label into the answer. And then that's going to serve 12 people, okay? All right, so to solve it, I'm going to do the inverse of what I did before. So the inverse of dividing by 6.5 would be multiplying by 6.5. So I'm going to multiply both sides by 6.5. Now, 6.5 divided by 6.5 is 1. 1 times x is x. So we have the inverse property of multiplication. We have the identity property of multiplication, right? Now over here, I'm going to have to do some math. So I'm going to just multiply 12 and 65, ignoring that there was a decimal point. So 10, 6, placeholder, 12, 6 and 1 is 7, add up. And then with 1 digit after the decimal point. So what I get is 78. So the size of the ham that Chuck should purchase would be 78, and the only label that we have to use for the measurement would be ounces. So I'm going to say Chuck should buy let's use that word, purchase. It sounds so much fancier. Chuck should purchase a 78 ounce size ham. And if you wanted to go really far, you could say to feed 12 people. Now, I'd be really happy if you stopped with Chuck should purchase a 78 ounce size ham. That would make me happy too. Okay, that's what you guys are going to be working on in class. All right, enjoy.